So we are going to be talking about introduction to Arduino. So what is a development board? What is an Arduino? How do you use it? So those are the questions we are going to be answering today in this class. So I think everybody can see my screen. Up here I have like different models of the Arduino, and down here there's a picture. Don't mind that right now. Explain better. So move on. Next slide. So what is a development board? In the last class, Raji talked about microcontrollers, and he explained, I don't know, but in the last class, I think microcontrollers, then he explained that they were like a chip that you would find the processor inside, you'll find the RAM inside, you'll find the flash memory inside, all coupled into a single chip. So that's what a microcontroller is. Hello? Hello? Hello?
Hi.
Thank you. And someone said the statics are not, I didn't get that. Okay. So he explained that microcontrollers have processor, RAM, and flash, and some other peripherals inside, all coupled into a single chip. And that's what he said the microcontroller was. Now, if you attended the last event we had, where Mr. Kayode Alade talked about embedded systems. He talked about introduction, what you need, and when it comes to embedded system generally, you have microcontrollers, you have your processors, and the rest of them. So classification of microcontrollers. I already explained what a microcontroller is, what are the different types there are. So when you're looking at microcontrollers, you look at them in terms of bits, like how many bits they process per clock cycle. Look at it in terms of memory or memory devices. Some have like their flash embedded inside, some don't have that. And you look at it in terms of the family, that's like which company designed them, and then the instruction set. This has to do with the assembly code, like or the machine language, like how many instructions does it take, how complex they are, how reduced they are. Okay, this is like compressed instruction set, while reduced instruction set. Memory architecture. This has to do with okay, how your CPU communicates with your RAM, or how those processors communicate with the RAM inside the microcontroller. Now, how does data flow? Does it flow from your memory to your RAM to your CPU? How's that information being carried? How's that information extracted and used within your microcontroller? How instructions executed? So that has to do with your memory architecture. So you have the Princeton and the Harvard. So under families, which is the most common classification we can find, we have the 8051, which is manufactured by Intel, Atmel, Delaz, Philips. We have microcontrollers, Motorola's, yeah, PICs, Taxes, where under ARM you could have like STM32, and we have the AVRs. Sorry, it's not here. The AVR is supposed to be somewhere here under others. So under the AVR, that's where you start talking about your at mega this, at mega that. So okay, let me come back to answer the question. What is an Arduino? Uh, if you can look at the pictures, yeah. Sorry, can someone? I'm not sure if you're hearing or listening. Hello.
Hi.
Okay, that's much better. So if you look at this, the pictures I have here, you'll notice one thing in common. This, I think you can see my mouse, right? Hello? If you can see my mouse, please say yes.
Yes.
Okay. So if you notice one thing in common, I'm going to point out this, 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 and this. Let me go to other pictures. Just make it more clear. This, this, and this. I think I've made my point. Now, those things I just pointed on these circuit boards, they are the microcontrollers. Yeah. The microcontroller here is most likely an Atmega under the AVR family. If I was going to call out the part number for the microcontroller, that would be Atmega 328P. And this one, now if you notice, the two of them are the same thing. They're the same chip, all right, but they have different forms. This one is in pin format. This one is in this other format, but they are still the same thing. So you notice that there are a group of like their circuit. You see like a whole circuit around around the whole microcontroller. Now you see something here that has a crystal. That has something for USB. The other ones maybe like power supply, pin out. That's a button. That's some jumper. That one over there. Now these are additional components added to your microcontroller to help it function, carry out the basic functionalities. So coming back to the question, what is a development board? The development board has all these additional circuits on it to help you use the microcontroller you are interested in using. It's usually like development, like the name implies. It's used when you want to develop a product. I don't want to go straight up, okay, buying the microcontroller, assembling it on the board, putting all the peripherals you need before test running your project. So just use a development board which really has all those things on it, and carry out your prototyping. So that is what the development board helps us to do, help us rapid prototype our products. So this here we have an AVR development board. The chip on it, I think we can see the part number 8090 USB 646. I think that's a part number. You could type this in on the internet and it will bring out information concerning this particular microcontroller. Now, I think I've explained that. I won't go into further details now. But you can see the basic circuit. This is the USB port. These are just pins out. And you see they're labeled. Each pin has different function and what it can do. Yeah, this is the picture of the famous Arduino. And if you look at it closely, you see this chip there. That is an Atmega 328P. That's the part number. It's under the AVR family. If you look at over here, you have like additional circuit to help it function. I think this one is for connection to the computer so you can program it like you can see here. This is a power supply, and this is a crystal. I'll explain that later in the other classes. Okay. So we talked about development board. This example of more sophisticated development board. So this is actually like wrong spelling. Okay. Okay. So if you look at this one is more complex. It has more components. It has an LED display, some other display here. It has a new board so you can put out some resistors and LEDs there, some key switches, and a bunch of other components to help you prototype. So back to our Arduino. So what do you need to actually code this board? How do you use it? Is it just like a fancy thing keeping your room for decorate, or just the beauty, or just to decorate your room? Okay, let me bring out a picture where this has actually been used in project. Hmm. So, but now listen. Okay, let me bring out this picture. I want to explain something. Like we said, development board usually has a basic component so that you can interact with this microcontroller. Now, if you look here, it has pins. Each pin has a different function it can perform, what it can do. Now, through these pins, you connect these different devices to the microcontroller. You can't connect it directly because maybe like power supply, current, other specification, but you can connect it to the pins, pin out, these pins here. I'll show you how to interact. We'll show you how to interact with those pins as time goes on. So what do you need to actually build stuff with this board? Well, you need a development board, which is the Arduino. Need an IDE, and you need know-how. How to get know-how, tutorials, books, documentation. There's something else I wanted to mention. When people usually talk about the Arduino, they are referring to the whole ecosystem around it. That's you have the board, but then when you get to programming it, you have an IDE for it. What's an IDE? Integrated Development Environment. Hello, sorry. Are you following? I don't know if I'm talking to myself.
We are following now.
Is there anywhere I should like read through,
Hello.
like come back, repeat, or point out more?
Not really, sure.
Okay, we'll carry on. So what are the things you need? Like I mentioned earlier, you need a development board, which is the Arduino, the IDE, and an Arduino has an IDE. It's called the Arduino IDE. And IDE stands for Integrated Development Environment. So I'll explain that better later on. So the know-how, tutorials, books, documentation. Let me open your Arduino IDs for you to know what I'm talking about. So this is an application on my laptop. Is it? It's loading. We use it in typing the code that is going to run on the microcontroller. Compile it to an object code. Compile it to an object code, and that object code is uploaded to your microcontroller. That's the one that runs on it. So I wanted to introduce you to something else today. When we talk about simulators, now I notice that it's not all the time you have access to your microcontroller or electronic components. Hello? Hello?
Hi.
Okay. I thought someone was asking a question. So it's not all the time you have access to a microcontroller, like physically there with you. So in that case, most times or electronic components. So in that case, most time we use okay, it's loaded. We use a simulator. Simulator, like the name implies, simulate the circuit. I could assemble a whole circuit and put in some parameters, specify, okay, this is the amount of resistance we have here, amount of current that should pass here. This is a component that should use here. and to show me how that circuit will work in real life. So what is an example of a simulator in electronics or in embedded systems? We have SPICE and we have Proteus. Those are the most common one. Now, SPICE is used for simulating electronic circuits. That's when you have like your resistors, your capacitors, your all the circuit. When you assemble them, it's used in simulating them. Now, in Proteus, you could use it to simulate that, and you could use it to simulate other things too, like microcontroller. You could simulate a whole microcontroller on your Proteus. As write code to it, upload it to the simulator microcontroller, and it will run, interacting those peripherals as you would want them to. So I'm going to show you a basic demo of Proteus. I think I have it here on my laptop. Let me start the application. Okay, we only have like 7 minutes left. So this is the basic workshop center. Okay. So yes, this is one of the codes one of the project I'm working on. Can you see the screen?
No, we can't.
Okay, let me open it. Okay, you can see it now, right?
Yes.
Okay. Okay, under preferences, I wanted to use another editor. It's like another app to edit my code. So I use external editors. I mean, to edit it here. So yeah, this is an Arduino IDE, Integrated Development Environment. Why is it called that? Because I can type my code here, like I've done here. This is a more complex piece of code. Don't worry. I can type my code here. I can compile it. I compile it and upload it to my board. I connect my Arduino to my system. I press upload, compiles it into the object code, and push it to my Arduino. That uploads it to my Arduino so I can run it. I'm going to do something similar. I'm not attaching any Arduino to it, so it will definitely return an error that I can't find it. Okay, and I'm sure you have a question about what is, like we've been talking about what do you say, object code. And does anyone have a question about that? Like what object code is, what have I been talking about? Are you curious? I guess not. I think I better skip it now. Should I skip it? Yeah. Okay, this program is not responding. Can you see Proteus? Hello? Hello, can you see this? Can you see this screen?
Yes.
Okay. So
Yes, sir, we can.
okay, that's good. So if you notice in those diagrams I showed you in the beginning, that slide, initial slide, you saw a bunch of development boards up there. All of them are part of the Arduino ecosystem. So I mentioned that when people talk about Arduino, they are not really referring to one particular board. They're referring to the whole system involved. So in the Arduino ecosystem, you have different development boards. And one thing that is common to them is the boards originally are manufactured by Arduino, and most of them have an Atmega chip there. There's an AVR family chip microcontroller attached to them, and they all use the Arduino IDE. Now, what is so special about the Arduino IDE is it has a bunch of libraries. We'll go on to explain what libraries are later. But if you're already familiar with code, you understand what libraries are. It has a bunch of libraries that help you program it much more faster. That reduces your development time, makes it so much easier for you to program these things. So here I've opened your approaches, and this is a project I'm working on. So you have an AtMega, which is an Arduino board, and you have a bunch of sensors here, and you have some relays here, and you have some light bulbs here. Now I'm going to upload a an object code. Now I remember I told you that okay, Arduino helps you compile your code, right? Now when it compiles it, you can have you can save the object code somewhere in the file. And sometimes when you just compile it and upload it, it just uploads, it doesn't save it. So here it has saved it inside this file. So it's the object code that is pushed to your Arduino. I know if I should mention this, it can be confusing, but just bear with me. So you write your code using normal C++ or C or the Arduino flavor of C++. It's a programming language. And it compiles it down to binaries so that your microcontroller can understand what you've written. And it's those binaries that are uploaded to your microcontroller. That's what runs on it. So here in your Proto simulation, you would have to use those object code, which is that compiled code of yours. So I'm going to run this simulation here. You look at it, loading libraries, running it. Okay, so it's running. Okay, my laptop is a bit slow. Okay, there's an error. There's an error. Yeah, well. Yeah, I think that is best now. Okay, I should have prepped this for this class. Mm. Okay, let me do something quickly. Okay, our class is should be done anytime soon. Let me show you something. Let's put binaries. Okay. So yeah, it's running. I think we can call it a day for this class. The next class, we're going to be treating what this actually is. That's how to use your approaches. So let's go over what we've done for this class. Let me go back to the slide. There's a bug there. I'll fix it later. Okay, let me go. Let me go back and see if I can do that. If you're with me, let me just check my code. Okay. I'm compiling. Yeah, please run, please run. Make me go back to my code. Okay. Yeah, just a sec. Oh, three. Okay, 115 200. That's a problem. Yeah. 115 200. Yeah. Okay, please run. Oh yeah. There we go. Sorry, can you say this? Hello? Hello?
Hello.
Yeah, can you
Yes,
say?
sir, we can.
Oh, okay. So this is taking input from these sensors. Let me zoom in a bit. This is like your distance. This is like your temperature. So you could like introduce it here. It measures it periodically actually and displays it to the screen. Should adjust that code, has some delays inside and use interrupt. Oh, why is this behaving? Okay. So there we go. I think this is good for a basic intro. So let me just go through the slide quickly and we'll call it a day. So in this class, we looked at introduction to Arduino. We looked at what is the development board. We were able to answer what is an Arduino or what is Arduino. When you say what is Arduino, like referring to the whole ecosystem. How do you use it? So to understand what development boards, we looked at what microcontrollers are. We looked at the classification of microcontrollers, and we looked at why you need a development board. And we looked at examples of development boards. We looked at the classification based on bits. We'll go over this maybe later in the future when it's dealing with registers to get to understand all these things much more in-depthly. Showed you different examples of development boards, what an Arduino is, like example of one, and what are the things you need, development environment, the ID, and the know-how, tutorials, books, documentation, and what a simulator is. And I also went over, going further, I'll tell you that okay, Arduino has different boards, and you have the Atmega, you have the Nano, you have the Uno, and there are a bunch of other them also, other boards also. And one thing common with them is most of them use an AVR chip, or they're manufactured by the Arduino company. They're originally manufactured by the Arduino. Arduino is a company, open source community, but it's a company. Now they all use the Arduino IDE. And how do you program an Arduino? The language is in C++, really, but then it has a bunch of libraries, and we just call it Arduino. Yeah, so it's C++, really, and they made it so simple to write code, to a microcontroller. We'll go over this in the next class when we are running the simulation. So, any questions? Hello? Hello?
Hi.
Okay. Yeah. Okay. 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 Let's call it a day then. Okay. See you tomorrow.
Thank you. Thank you so much. Bye.
Okay.